Hey there, it's Miss Heaton, signing in to talk with you about significant figures. Today we're going to deal with objectives 4 and 5 from Unit 1, and these are the textbook pages that correspond to what we're talking about. First of all, let's talk a little bit about measurement. We already know that when you're making any measurement, you always record all certain digits and then add on one uncertain digit that you approximate. We have a new term that we're going to call those numbers. The numbers that you record, all the certain ones and then one uncertain one, are significant numbers. And we're going to call those significant figures, or sig figs for short. So here's kind of how this works. Let's say that we were measuring this lovely Words with Friends tile, and we wanted to know how long it was. If the ruler was only marked at 0 and 10, we'd have to say that's somewhere about 4. But with this ruler down here, we can say, oh, well, it's almost to the 4, so that's about 3 and some change, so about 3.9. And with this ruler here, we're able to say that it's 3.9, and it's between the 9 and the 3.9 and the 4, so 3.95. So on each of these numbers, each of these measurements, we have a different number of significant figures. And let's talk about how many significant figures each of these have. Well, if there's no zeros, it's pretty easy. Any number that's not 0 is significant. So this one has 1 sig fig, this one has 2 sig figs, and this one has 3 sig figs. That's why the more exact your measuring device is, the better your measurement's going to be, because you get more numbers that are significant. In your book, there's a bunch of rules listed, and here's kind of my rewording or summary of those. So you can refer to page 25 if you'd like to see it in the way your book lists it. But here's how you know if a number is significant. As we just talked about, if it's a non-zero number, it's 1, 2, 3, 4, 5, 6, 7, 8, or 9, it is significant. If it's got a 0 in it, and that 0 is sandwiched between two significant numbers, a 1, 2, 3, 4, 5, 6, 7, 8, or 9, that 0 counts as significant. And if it's a 0 at the end of a number, and there's a decimal point in the number, that 0 would be significant. The number won't be significant if it's a 0 and it's at the beginning of the number, so it's 0.000001, only the 1 would count. And if it's a 0 at the end of a number that has no decimal point, that 0 at the end will not be significant. This is really best seen in practice problems, so let's try a few here. The number 5, how many sig figs will it have? Well, let me change color pen so we can tell the difference. This would have 1 sig fig because of this rule right here, a non-zero number. If we had the number 5.0, we know that the 5 is significant. What about that 0 at the end? Well, we have two rules about zeros at the end. If the zeros at the end and the number has a decimal point, that 0 is significant. So this 0 is significant. So this would have 2 sig figs. If there had not been a decimal place there, that 0 would not be significant, and there'd only be 1 sig fig. How about this number? Well, we know that the 2 is significant because it's a non-zero number. What about the zeros at the beginning? Where are rules about zeros at the beginning? Oh, zeros at the beginning are not significant. So those zeros are not counted as significant. The reason is because they're just there to tell us that this is a really small number. It's 0.02. We couldn't write that any other way. So that would have 1 sig fig. Okay, try this one. We know that the 2 is significant. We know that the zeros at the beginning are not. What about the 0 at the end? Well, the 0's at the end, and the number has a decimal point in it, so that 0 is significant. So that would have 2 sig figs. Can you ever have more than 1 or 2 sig figs? You betcha. Why don't you try this one on your own? So hit pause, and then hit play again when you think you got it. Okay, so we know the 5 and the 6 and the 4 are significant. We know that zeros at the beginning are never significant. What about this 0 that's here in between numbers? This rule says a 0 that falls between sig figs is significant. And then what about zeros at the end? This number does have a decimal point in it. So if there is a decimal and the zeros at the end, it is significant. Because we went to all the trouble of writing that 0, we wouldn't have had to if we weren't sure of it. So there's 1, 2, 3, 4, 5 sig figs in this number. Here's a couple more. I think that's the last one. Oops, sorry. Here's the last one. Last 2 for this page. Give those a shot. So hit pause and then hit play again when you think you got it. Okay, for this number, we know that the 2 is significant. How about these zeros here at the end? There is no decimal point in this number, and those zeros are at the end. So they're just there as placeholders to tell us that it's a big number. So whoops, this one has 1 sig fig. And how about G? Well, we know that 2 is significant. A 0, well, okay, these zeros in the middle, a 0 that falls between significant numbers will count. Well, let's come back to these zeros in the middle. How about this 0 at the end? At the end, and there is a decimal point in the number, so this 0 is significant. Now these ones in the middle are between significant numbers now, so they also count. So this one must have 1, 2, 3, 4, 5 sig figs as well. A couple additional rules before I turn you loose here. If you are writing a number in scientific notation, all numbers before the times sign are going to count as significant. Any numbers after are just there to tell you how big or small the number is. So in 2.0, there are 2 numbers before the times sign, so there are 2 sig figs. If you had just written 2 times 10 to the third, there would only be 1 significant figure. Even though both of these are expressing the number 2,000, you know, 1, 2, 3 would be 2 times 10 to the third. You would write 2.0 times 10 to the third if, according to your measuring device, the 2 and the 0 were significant. That's how you'd write it, 2.0. Oops, covering up my next step here. If you have an exact number, that number will have infinite sig figs. Well, what does exact mean? If it's something that you're counting, like I have 5 chickens in my backyard, you are exactly sure that you've got 5 chickens in your backyard, so 5 would have infinity sig figs. If you have a number that's if you have numbers that are in an equality statement, that would also have infinity sig figs. For example, 1 foot is always exactly equal to 12 inches. So the 1 and the 12 both have infinity sig figs in those cases. Let's try rounding now. Rounding is going to follow similar rules for sig figs. You're going to have to use those rules, but as we're going to see in a little bit, calculations often cause us to have to round a number that we calculate to sig figs. So let's practice here. In this case, I'm asking you to round to 2 significant figures. You could round to any number of sig figs, but for now we're going to try 2. So start with the first number that you're given that's significant. It has to stay. And we need to have 2 sig figs. So 5.2, the 5 and the 2 have to stay, and everything after it has to get chopped off. However, we have to follow rounding rules. If the number that's getting chopped off is 5 or greater, we round up. So this will become 5.3. Let's try the same thing on the next one. The first number that has to stay is the 5, and we need a second sig fig, so the 4 has to stay. The number after it's getting chopped off is a 2, so we won't have to round up. So you might be tempted to write this as 54. Now think about that for a second. Is 5,421 close to 54? No. Those are very different numbers. So how would we write 5,421 with 2 sig figs? What is it close to that would have 2? Well, what we can do is keep zeros here as placeholders. 5,421 is close to 5,400. Try the same thing with J. We want to have 2 sig figs, so the 3 and the 9 get to stay. Anything after that has to get chopped off. Although we know that this times 10 to the third means it's a really big number, so that times 10 to the third is going to have to stay. And it doesn't count against our 2 sig figs that we're allowed to keep. This 9 causes this 9 to get rounded up, which causes the 3 to get rounded up. So that means we've got about 4. 3.99 times 10 to the third is pretty close to 4 times 10 to the third. But if we just wrote that, that would only have 1 significant figure. So we can add on a 0, 4.0, to show that this is got 2 significant figures. Okay folks, here's your challenge. Try these next 3 on your own. Again, rounding to 2 significant figures. Bring those to class, and we'll see how you did.